All right, we're going to work on lesson 102 today. So, lesson 102 deals with transversals and simplifying equations. So, the first thing we're going to talk about is the transversal. So, a transversal is a line that intersects two or more other lines. So, in this figure, I have two lines, S and T. And this transversal intersects those lines. So line R would be considered a transversal. So again, that's just a line that intersects two or more other lines. So some terminology that we need to know. First of all, we have what are called alternate exterior angles. Alternate exterior angles means that a special pair of angles are formed when a transversal intersects two lines. Alternate exterior angles lie on opposite sides of the transversal and are outside the two intersected lines. So what would alternate exterior angles look like? So if I look at this figure, okay, we have a transversal P that intersects lines M and N. The alternate exterior angles lie on opposite sides of the transversal. So one would be on this side of the transversal, one would be on the other side of the transversal. And they are outside the two intersected lines. So exterior is outside of the two intersected lines. We will talk about interior, which would mean inside the two intersected lines. Alternate exterior, angle 1 and angle 7. They are on opposite sides of the transversal. Okay, so those would be alternate exterior angles. The same relationship would work with angle 2 and 8. Okay, they are also on opposite sides of the transversal and they are in the exterior portion. We also have what are called alternate interior angles. So this is a special pair of angles formed when a transversal intersects two lines. The alternate interior angles lie on the opposite sides of the transversal and are on the inside of the two intersected lines. So if we looked at alternate interior angles, so again, interior between the two intersected lines, opposite sides of the transversal. So angles 3 and 5 would be alternate interior. 4 and 6 would be alternate interior angles as well. We also have what are called corresponding angles. So corresponding angles, a special pair of angles formed when a transversal intersects two lines. Corresponding angles lie on the same side of the transversal. So that's what's different here. We have the same side of the transversal, and they're in the same position relative to the two intersected lines. So when we talk about corresponding angles, we're talking about angles that are in the same positions. Okay, so if I look at this figure, angle 1 is in the top left-hand portion of these four angles that were formed. So angle 1, top left. If I look at these four angles, top left would be angle 5. So angles 1 and 5 would be corresponding angles. Okay, if I look at top right hand of these four angles that were formed, angles 2 and 6 are corresponding angles. Bottom right, 3 and 7. Angles 3 and 7 are in the same position, so those would be corresponding angles. And angles 4 and 8 would be corresponding. So top left, top right, bottom right, bottom left, bottom left. Okay, each of those pairs would form corresponding angles. So what do we gain from this information of knowing the alternate exterior angles and the alternate interior angles and the corresponding angles? Well, when a transversal intersects parallel lines like lines F and G, all of the acute angles formed are equal in measure. So all of the acute angles, angle 4, angle 2, angle 8, angle 6, all of those angles are equal in measure. Okay, there, and then all of the obtuse angles formed are equal in measure. So angles 1 and 3, 5 and 7, all of those obtuse angles are going to be equal as well. Remember, this only works if I have parallel lines that have been intersected by a transversal. So therefore, any acute angle formed will be supplementary to any obtuse angle formed. So if I know the measure of angle 4, this acute angle, I know that angle 4 and angle 1 together form a straight line. So they have to add up to 180 degrees. Okay, the same thing with angle 4 and 3. They form a straight line. So angles 4 and 3 have to be supplementary as well. Now, the thing is, they don't have to be right next to each other anymore. So angle 1 and angle 6 are going to be supplementary because I have an obtuse and an acute angle. So those two angles would add up to 180 degrees. All right, so I have a couple of questions that we need to answer on here. Let's start here. What's the transversal on this page? Is it line F, line G, or line C? Remember, the transversal is the one that intersects two lines. So line C will be my transversal. So line C. What is an alternate interior to angle 3? So here's angle 3. Interior, remember, is on the inside of the two lines that were intersected. So alternate is opposite side, inside. So angle 3 would be an alternate interior angle to angle 5. Angle 5. Which angle would be corresponding to angle 8? So corresponding, they need to be in the same position. So angle 8 in these four angles is upper left-hand side. The corresponding angle then would be upper left-hand side in this group. So it would be angle 4. Okay, what is an alternate exterior to angle 7? Angle 7 is down here. Alternate means opposite, so opposite side, exterior, outside. So angle 7 and angle 1 would be alternate exterior angles. So the alternate exterior to angle 7 is angle 1. Now, here's the big one. If angle 1 is 105 degrees, let me mark that on here, 105 degrees. Find all other measures. Okay, what do I know about every obtuse angle then in this figure? Every obtuse angle is going to be equal to this. So angle 3 is obtuse, 105 degrees. Angle 5 is obtuse, 105 degrees. Angle 7 is obtuse, 105 degrees. So I'm halfway finished. Now I need to find the measure of an acute angle. And then all of the acute angles are going to be the same. So let's just take angles 4 and 1. They are supplementary because they form a straight line here. So whatever this is, plus 105 has to equal 180 degrees. So if I take 180 minus 105, I will come up with 75 degrees. So angle 4 is 75 degrees. Angle 2 is 75 degrees. Angle 8, 75 degrees. Angle 6, 75 degrees. So now I have found all of the other measures in this figure. All right, the second part of the lesson deals with simplifying equations. I think you're going to find this very easy. So if I have this equation, I have 3w minus 10 plus w equals 90. So in order to solve for w, first I have to combine like terms on each side or either side. Okay, so I have a 3w plus 1w. That's going to give me 4w. So 4w minus 10 equals 90. Now let's get the w's by themselves. So add 10, add 10. I get 4w equals 90 plus 10 is 100. To solve for w, divide by 4, divide by 4. That gives me w equals 100 divided by 4 is 25. So the only new part here is being able to combine these like terms before I try to isolate the variable on one side. Okay, let's look at this last one. 3x equals 2 times, in parentheses, x minus 4. So I know that I have to do this multiplication before I can solve. So my 3x stays the same. So 3x equals, let's distribute. 2 times x is 2x. 2 times negative 4 is negative 8. Okay, now I have to get those variables on one side. So I usually like to move them to the left-hand side. That's just force of habit. So let's move these x's over to this side. Well, I have a positive 2x here, so I have to subtract 2x. I also have to then subtract 2x on the left-hand side. So 3x minus 2x just gives me an x equals, those are going to cancel out, and I have negative 8. So x equals negative 8. All right, have a great time working on this lesson.